Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome back. So, we will continue our discussion on the solid propellants, and under the solid propellants we are talking about the propellant selection criteria. In the previous lectures you have seen that the choice of the propellant will very much depend on fulfilling the major criteria of the rocket. For example, like it needs to provide high performance means high ISP or high C star. And there we have seen that in order to achieve high ISP, the temperature of the combustion products must be higher, and the temperature of the combustion products will be higher only when the heat release from the combustion of the propellants is higher. And we have also looked at one equation where the heat release from combustion reaction was related to the heat of formation of products and heat of formation of reactants. And there we have said that in order to have high heat of combustion, we need to have large negative heat of formation values for products and small negative or even positive heat of formation values for reactants. Now, I will show you one table here where you can see some of the typical heat of formation of various products. For example, like if the fuel is aluminum, the product will be aluminum oxide. So, you can see it has large negative values like -1620 kilojoule per mole. Similarly, like the other products, like if it forms CO2, you can see it is having like -393.5 and so on. I mean, there are definitely various other products also, like if we have HCl, you can see it is having -92. So, generally for the products we look forward to have large negative heat of formation, and for the reactants we want to have small negative or positive heat of formation. On the molar mass side, or which we said that molecular weight, we said that the product side molecular weight should be lower in order to have high performance, because ISP is proportional to 1 by square root of molecular weight. So, if you look at we already told ourselves that for solid rocket generally the mixture ratio is chosen slightly fuel rich in order to have some products of incomplete combustion. If you look at the molecular mass of CO and CO2, you can see the difference, and I think we have already shown through an example. So, if you look at the molecular mass of CO2 is almost kind of double, not exactly double, but at least 1.5 times compared to the CO. So, if the products are containing both CO2 and CO, the average molecular mass will be lower if the products are fully composed of only CO2. So, taking the advantage of the reduced molar mass for the products, generally the mixture ratio is slightly fuel rich for the solid propellant in order to take the advantage of the reduced molecular mass. So, I think we have discussed there, and we also talked about the density of the propellant should be high enough so that we can choose small volume motor, because we want to have like compact motor, and we all know that the rocket is a volume limited propulsive device. So, the volume is kind of restricted. We need to use the high density propellant in order to make the compact size of the motor. Okay. So, up to there we have discussed. Now, let us look at the other characteristics of the propellants, which will help us to choose the selections of the propellant. So, one such thing is that we need to have, like we said, that predictable reproducible burning rate. Similarly, it needs to have the predictable reproducible ignition quality also, like it needs to have reproducible and predictable ignition quality. Ignition characteristics. What does that mean? It means that whenever we are testing a particular propellant, the amount of energy needed for ignition, the pressure rising curve for that ignition process, they should follow exactly the same way when you repeatedly test it. So, the ignition quality or ignition characteristics should not change abruptly when we test the similar ingredients of the propellant several times. So, it needs to have reproducible and predictable ignition qualities. Like later on we will see, like for a large rocket, if you look at the pressure time curve, the ignition will start from like by increasing, the pressure will start increasing, it will fill the chamber, then ultimately reach to the equilibrium pressure. So, this is the P equilibrium. Okay. If you look at the schematic view of the rocket, you see the propellant grain is somewhere over here. Now, if you put this thing, this is the igniter. So, it will, let us say it will have some pyrotechnic igniter. So, there will be some ignition coil here. So, the igniter will create some ignition plume that will actually going to heat up the initial propellant surface, and that will start igniting the initial propellant surface, and that will fill up the volume of the the port volume of the grain with the combustion gases. So, the pressure will keep on rising, and it will continue till it reaches to equilibrium pressure, and then it will maintain for certain duration, and then it will tail off, means it will extinguish. Okay. So, this is typically the first portion of the this pressure time curve is the ignition, then chamber volume, like chamber has to be filled up, it will reach to a certain pressure, ignition will be maintained, ignition will be sustainable, and it will go to the equilibrium chamber pressure. Now, if the ignition fails due to certain reason, like let us say suddenly there is a spike in the pressure and then suddenly it falls, we do not want that. We want like kind of a predictable and reproducible ignition quality of the propellant every time. So, this is important criteria. We do not want any kind of a misfire or any kind of a hang fire. So, the ignition has to be like has to be proper. So, those type of processes we will talk later once we talk about the combustion processes of solid propellant. But at this point we should remember that the ignition characteristics of the propellant should be reproducible and predictable. Okay. There should not be any abrupt ignition or any kind of a unevenness in the ignitions once we repeatedly test it. The other criteria, of course, that once we make a propellant grain, it does not mean that we always use it immediately. Okay. So, we may need to store it for future use. So, the ingredients should be good enough that it needs to maintain certain aging characteristics. I mean it needs to have like long life and good aging characteristics. So, let us say we made the grain, for example, like if we make like cartridge loaded grain, we know that it is a freestanding grain, the grains are made separately, they are casted, cured separately, and whenever is required they are loaded into the rocket motor. So, if it is not needed, let us say for missile applications, it is not always necessary that we make the grain and immediately use it. So, they may be stored in the storage areas. So, the chemical property or chemical quality of the propellant should be maintained for a longer period of time. So, that is why the long life and good aging characteristics needs to be maintained or needs to have with the propellant. So, we can say that long life and good aging characteristics. Of course, this will depend on the type of ingredients we are using, like the propellants chemical and physical properties, that will of course tell us that how long it is going to be stable or without further chemical deterioration. But in summary we say that the propellant should have the characteristics of long life and good aging. So, it will maintain the its quality for a longer period of time. It should not absorb moisture. So, absorb moisture should be minimum, it should, even if you absorb, it should be minimum, because sometime it may so happen that due to the absorption of moisture there may be some chemical changes, like it may change its crystal structure, maybe it may create some void inside the space of the crystals for certain oxidizers, these may so happen. The chemical property or chemical quality of the certain ingredients may even change. For example, like certain metallic fuels, if they absorb moisture, they may not be may not remain the same good quality. Certain crystals, they may form a different type of crystal phases, which will actually eventually lead to its lower quality of performance. So, the propellant should have the quality that it should absorb minimum amount of moisture. Okay. Then of course, while making the propellants, the process of making, or we can say the process of manufacturing the propellant, manufacturing of propellants, that process itself should be simple and low hazardous. We want to make the propellant means we are talking about the fuel and oxidizers. So, manufacturing process for making those propellants must be simple and low hazardous. Of course, it needs to have like raw materials should be available all the time. So, we need to make sure that the raw materials are available for the propellant, and it may require for quite some time. So, we should make sure that the availability of the raw materials is guaranteed, okay, for at least some period of time, or we can say over the production and operating life of the propellant. And we need to have good control over the impurities present in the each of the ingredient, like percentage tolerance, how much percentage of impurities cannot be nullified fully, but the tolerance limit of the impurities we should know, and we must have the good control over the impurities limit. Okay. So, that is another important criteria. It must need to have like some prior experience, or the risk of handling or performing or operating of the propellant should have like technical risk should be minimum, should be like minimum. We need to have some kind of a prior experience handling the propellant, that will give us the confidence for choosing the certain propellants for certain application. Now, let us say we make the propellant grain, but if there is any kind of a external stimuli, the ignition itself is an external stimuli, but there may be some unintended external energy stimuli may be available. So, the propellant must have the enough insensitivity. So, the propellant should be insensible to like certain energy stimuli or certain energy sources, which we need to order to avoid intended ignition. Okay. What does that mean? That means, let us say we have loaded the propellant in the rocket motor. Now, this rocket motor can be subjected to various, while during transportation it may subjected to like vibration. Now, the vibration may cause some, some segments may not be aligned properly, there may be some little bit of tolerance is there. So, due to that it may cause some kind of a energy absorption into the grain. So, that should not lead to certain ignition. There may be some stray currents, there may be some impact like some dropping of something, some materials dropped on the propellant, there may be bullet penetration also. So, there are should have the quality of the propellant in such a way that it can avoid the unintended ignition. So, there are certain energy stimuli like there may be like fires, fire may break out nearby areas. So, just due to the radiation heat, like it should not absorb enough heat that it may lead to some unintended ignition, because the ignition was given only through this igniter, right. What we have just said, that igniter will create the ignition plume and it will create the ignition process. But if there is some other energy sources like heat or even dropping of the propellant or even the certain external like stray currents or even by the like bullet penetration or even by the vibration or even by the like electrostatic discharge, which may be caused due to some friction of the insulating materials, that should not lead to any kind of an unintended ignition, that must be avoided. So, the propellant should be insensitive enough to avoid the unintended ignition. So, that is another important qualities. Okay. We need to of course low toxic materials, we need to have like low toxic propellants, and of course, this should lead to like non toxic exhaust. So, propellant is actually producing exhaust gases. So, we are talking about that it should not produce like toxic gases, which is going to create environment for the members working nearby areas, or also it is going to pollute the environment. But you see, for the general the very common ingredients for solid propellant rocket is the HTPB plus AP, which is kind of a workhorse oxidizer for most of the composite propellant. Almost all the satellite launch vehicle are using this combination. So, if you look at this ammonium perchlorate, which is a chlorine containing substance. So, on decomposition of ammonium perchlorate, it is going to create some chlorine compound and it is going to create HCl, which are not really good for environments, because they are kind of very reactive, they are not really benign to environment. So, although we are saying these things, but the major oxidizer used for solid rocket still not having the environmental benign quality in terms of like the exhaust gases. Okay. But of course, the choice of the propellant should be such a way that it should follow the non toxic exhaust characteristics. Okay. This is another thing. All right. Other choice is like it should not lead to combustion instability. So, if there is any pressure fluctuations inside the combustion chamber, your propellant, the burning of the propellant should not promote the combustion instability. So, the choice of the propellant should be such a way that it should somehow diminish the, even there is a fluctuations which may be subjected to some instability, but the propellant should not further increase the fluctuations, which may lead to like the complete failure of the motor. So, it should not it should not prone to the combustion instability. So, these are the several characteristics of the propellant are considered while making the choice. Of course, there are certain characteristics will be there for the particular choice of the mission, where a particular type of propellant is chosen. So, in spite of those things, there may be some other criteria which need to fulfill, for example, like the compatibility. So, it is not only the propellants only, but there are some insulator, liners. So, the choice of the propellants will also depend on them, that whether there is an issue with the compatibility of the components, or in between the propellants, if there is any competitive issue or not, whether they are maintaining the enough mechanical properties. So, it is like a trade off between the mechanical properties and the ballistic properties. So, the choice will be definitely depend on the propellants selection criteria. Okay. So, but majorly we have talked about these criteria which are supposed to be followed by the designer while choosing a particular propellant. Okay. So, now let us move ahead and we will talk about what are the major ingredients of solid propellants. Okay. Since we understood pretty much the major characteristics of solid propellants, now let us look at what are the major ingredients of there are a number of ingredients have been tried for solid propellants, but we will try to look at the major ingredients of solid propellants which are most commonly used. But we must need to acknowledge the fact that the principal ingredient, if we say that without which the propellant cannot work, the principal ingredients are the fuel and the oxidizer. So, these must be needed in order to have it as a propellant. Without fuel it will not work, without oxidizer it is not going to work. Now, fuel and oxidizer, they are the principal ingredients. In addition to fuel and oxidizers, there will be certain other ingredients which are going to have different kinds of role in order to have, like, they may increase the burn rate. So, there may be burn rate modifiers. If we have a polymeric fuel which is in general liquid in nature, but if we have to make it like a cured propellant, if you recall the definition of the grain, we said that cured mass or shaped mass. So, maybe the initial state of the propellant mixture or the initial state of the fuel and oxidizer mixture was a liquid or even slurry. Now, later on we actually cured it and made it a solid block of material which is grain. Now, there are certain ingredients required to enhance the process of curing. So, there will be some curing agents. There may be required to increase the burn rate of certain propellants. So, there may be like burning rate modifier or burn rate modifiers. There may be some catalyst. There may be some increasing burn rate, or there may be some catalyst for decreasing burn rate also. So, inhibitor, for example, like they may actually reduce the burn rate. So, depending on the requirements, there may be different type of ingredients which are used. So, it is not like just restricted to certain type of fuel or oxidizers, but there will be number of ingredients which have been tried. But in our discussions, we will just focus mostly on the major ingredients. Okay. So, let us look at what are the major ingredients we will try to consider. So, as I said, the fuel and oxidizer are the principal ingredients, but there may be like the name wise we can say it will have like fuel, it will have binder, it will have oxidizer, it may have like plasticizer, it may have like curing agent, it may have like burn rate modifier, and so on. There may be so many things are added depending on the choice of the propellant and for what purpose the propellant is being made. So, depending on that, there will be like number of different ingredients have been tried or are being tried even now. Okay. Now, coming to the fuel, what we just said about this one, if we just make like the propellant out of just the polymeric fuel plus oxidizer, there we can say it is like the only the fuel and oxidizer which is acting as a binder also. But if you look at here, we have just categorically mentioned fuel and binder, but once there is only polymeric fuel which is actually a binder. So, binder is nothing but it also acts as fuel as well, just because the polymer is hydrocarbon. So, it will eventually burn. So, that will act as fuel. So, if we do not have any kind of other metallic ingredients, if we just have like polymeric binder plus oxidizer, so the polymeric binder is nothing but it is a fuel. So, the principal ingredients we must need to have the fuel and oxidizer. Now, here once we say categorically fuel, so fuel means we are talking about like various metallic fuels. So, very common metallic fuels is the aluminum particles. They are considered as the common metallic fuels. It may have like diameter of 5 to 60 micron diameter. Okay. They are used widely, we can say like used widely in various composite propellants. Okay. Now, the size we have mentioned here, but there will be some different size of aluminum particles have been used, very fine particles, ultra fine, coarse particles. So, depending on the choice like and the availability, aluminum particles are used, but they are used in various composite propellant applications. Now, the problem with the very fine aluminum particles is that they will have some they will easily burn with air, and there will be some oxide layers with the present on the surface of the particles. So, there is a chance of that the particles will contain some oxide layer and the core of the particle will have aluminum. Okay. Now, choice of the metal particles are coming from because they are having high energy density, or compared to the normal hydrocarbon fuels, even polymeric fuels, considering their heating values and the metal fuels heating values, generally the metal fuel heating values are higher than the hydrocarbon fuels, but not always. For certain metallic fuels the heating values are higher, and particularly when it is the volumetric heating values. Volumetric heating value means the heating value per unit volume of the propellant, or you can say megajoule per meter cube. So, if you compare the heating values of volumetric heating values of hydrocarbon fuels and the metallic fuels, in many occasions the heating value of the metallic fuels are much higher compared to the hydrocarbon fuels. So, later on I will show you one comparative chart where we will see the heating values of various metallic fuels and the hydrocarbon fuels, where you can see that boron is considered to be very high, having very high volumetric heating value. So, boron is considered to be one of the prime choice, but there are some certain problems with boron particles. Although theoretically it shows that the heat release from boron combustion can be very high, but unfortunately the commercially available rocket motors utilizing boron as the fuel has not been utilized yet. Examples of using aluminum particles as fuels. So, here we are talking about mostly the metallic fuel. So, there are various choices considering the volumetric heating values. The other choices can be like boron particles. Now, other consideration I did not mention here is the density. If you recall, the high density of the propellant is another criteria we discussed in the previous class. So, here the metal fuel, the density of the metal fuels is higher than the density of the hydrocarbon fuels. If you look at the density of boron, I think it is around 2.34 gram per cc. If you look at the density of aluminum, the density is around 2.7 gram per cc. So, from the choice of the higher density of propellant, definitely the metallic fuels are giving the advantage compared to the normal hydrocarbon fuels. But the problem is there how to burn the metal fuel efficiently. So, there is the deficit lies that efficient combustion of these metal particles are not properly done. So, if they are not burning properly, the utilization of the energy is not very efficient. Okay. For example, like as we said the boron particles has the inherent tendency that it will covered with the native oxide layer. Like core part of the boron will have pure boron, but the outside layer there will be B2O3. So, which is going to cause inhibition to the ignition process, and eventually that will not lead to the complete combustion of the boron particles within the given residence time of the motor. Because you see we do not have like abundant amount of time for burning the particles. The typical residence time in a high speed propulsion system, the particles will not stay longer than few millisecond or maybe order of few 8 to 10 milliseconds. But within that amount of time, the complete combustion of boron and giving the energy release, the full energy release within the given residence time is somehow not achievable. So, even though boron is kind of a prime choice in terms of the metallic fuel, but it is still not yet achieved because of the issues with ignition and combustion process. So, in the next class I think I will bring one comparative chart of heating values of various metallic particles or metal fuels compared to hydrocarbon fuels in order to understand the choice of various metal particles. Okay. With that let us close the lecture today. Okay. Thank you.